In this question, we have a circuit in which you have a cell, a voltmeter, and an external resistor 6 ohms. Initially, the switch is open, so this is an open circuit. It's mentioned that the reading on the voltmeter decreases by 20% once the switch is closed. We have to find the internal resistance of the cell. So just for the ease of understanding, let us draw internal resistance of the battery. Let's say R, and let's say E is the EMF of the battery. So the battery is composed of the EMF as well as the internal resistance. Before we solve the question, let's revise the concept of terminal potential difference. So here we go. The terminal potential difference is the potential difference across the battery. So have a look at this circuit diagram. We have a battery, EMF E, internal resistance R. TPD stands for the terminal potential difference, which is the potential difference across the entire battery. And the formula for that is E minus IR, where E is the EMF of the battery, I is the current which is flowing in the battery, and small r stands for the internal resistance. Now, in this, the current I, we will find using the Ohm's law. V is equal to IR. So potential difference, delta V divided by the total resistance. In this entire circuit, the source of potential difference is the battery. Hence, potential difference is EMF. So potential difference will be equal to E, and the total resistance. So in the circuit, you can see small r and capital R are in series. So we add them to find the net resistance. Let's apply this logic in this question. So they are saying the reading on the voltmeter decreases by 20% when the switch is closed. So let's say if we close the switch and now it becomes a closed circuit. So the current will start to flow. It will have some current I. Let's draw the arrow. So the current will flow in the anti-clockwise direction. This is case 2 when the switch is closed. So what will the voltmeter read? Voltmeter will read the entire potential difference across the battery. So case 2, let's write V2. V2 stands for the voltmeter reading in the second case, and that is the terminal potential difference, that is E minus I into small r. In case 1, when the switch was open switch means current is equal to 0. So if we put current is equal to 0 in this expression, the terminal potential difference is equal to the EMF itself. So in case 1, let's write V1. V1 is the potential difference across the battery in an open circuit. So that is equal to E. They have mentioned that the reading on the voltmeter decreases by 20% in case 2, which means V2 will be equal to EMF E minus the 20% of E. Now 20% of E will be written like this. And let's simplify this. E minus 20% of E is E upon 5. If we simplify this, we will get 4E by 5. So now we have two equations. Let's write V2. V2 is 4E by 5. So we'll write 4E by 5 equals to EMF minus I into small r from this particular expression. So how do we find current? We use the same logic, total potential divided by total resistance. So in this case, the total resistance will be 6 plus R and the total potential will be EMF. So instead of current, we will write down the EMF E divided by total resistance, which is 6 plus R. So let's put all the values in. Let's simplify. On the left-hand side, we'll get 4E by 5 equals to E minus the current is E upon 6 plus R multiplied by R. So let's simplify this. Let's make E as the common term in the right hand side. So we'll get 1 minus R upon 6 plus R in the bracket. On the left hand side, we have a 4E by 5. E will get cancelled out from both sides. Let's simplify. So we'll get 4 upon 5 equals to, now in the bracket, if we take the LCM, we'll get 6 plus R in the denominator, and in the numerator, we'll get 6 plus R minus R. Let's simplify this further. 4 by 5 in the numerator, we'll get a 6. In the denominator, we have a 6 plus R. Now we can cross multiply. So we'll get 4 times 6 plus R equals to 5 into 6. 4 6 are 24 plus 4R equals to 30. 4R comes out as 6. And now if we simplify, R will come out as 6 by 4, which is 3 by 2, hence 1.5 ohms. So the internal resistance of the cell is 1.5 ohms, which is option B.